and Natalie's here as well. We're doing our group meeting for biology. Um, what questions did you have?
Well, every single problem was pretty much the same. It's like,
I know. After
Yeah.
5 times, I was like, okay, I think I get it.
yeah, I think I get it too. I mean, for the most part, I just kind of like followed what she did in the
In the
video.
video, yeah.
Yeah, and I
Me
was just
too.
like, okay, it works, you know.
So
So
reading was really, I was like, I don't get this. Then I looked at the video. I was like, okay, I can do that.
yeah, the video makes a lot more sense too.
Yeah, that was
Because
super helpful because I was kind
Yeah,
of lost when I was reading.
same here. And I was like, not really sure what's going on.
yeah, yeah.
Okay.
Although, like, well, I mean, we're doing the teach one another problem. That's what we're talking about. But um, yeah, I actually have a few questions on the next assignment, but that's not what we're
Uh,
doing for the.
I mean, if you want to do that, I'm okay with it.
Yeah, I haven't really worked on it yet, but
Yeah, but it's good to review with someone else because it get kind of like it's a few things is most part is just the same, but there are a few like things that are iffy. But maybe we can just go through one and then um, we'll talk about that after, just so we have because we're doing the teach one another problems for the group ones, I think.
hmm So
Uh,
you're talking about maybe going over a problem with the applying genetics
no, no,
assignment.
no. I'm saying we could probably just do one problem first, then maybe stop the recording because that's what we're supposed to give her. We're talking.
Oh, okay, okay, I see what you mean. I would like to hear all your guys' answers on like some of them, you know, just to make sure
But
that
you can look at the key.
Yeah, I always check mine at the end.
Yeah.
I guess I could do that, yeah. Good point. Hey, I keep forgetting about the key, alright?
Huh?
I keep forgetting about the key, alright? I
Yeah.
keep forgetting we can check our answers. Yeah,
So
I'm just
which
gonna
one should we do?
Uh, Anything's good. Do you just want to do the first one since it's there?
Yeah, sounds good to me.
The
All
first one?
right.
Okay.
So we kind of start this the way that we did in the last unit, right?
Mm-hmm.
Is that how you guys started it too?
Mm-hmm.
Just like
What do you mean?
figuring out what you should be expecting.
Oh, for the first one, I followed the video.
Yeah. I just kind of wanted to know, get a rough idea of what I should expect. I don't know if it worked well, but
Uh-huh.
I tried that. Um, okay. Do one of you guys want to go through and explain it?
Sure, I
Sure.
can go. I can go
Okay.
ahead and explain it. So the deal here is that pretty much for every single one of these problems, we got a heterozygous parent, usually for
Mm-hmm.
three traits. It seems like for most of these problems, it's three traits.
Yep.
Is crossed to like a completely true breeding recessive parent. Okay, and they give us the observed rates of basically every kind of phenotype you can get
Mm-hmm.
out of all the different genotypes, okay? And our goal is to determine exactly like what order they're in and how far apart they are from each other on the chromosome. I mean, relatively speaking, you know, because just like generic map. And then how much of it like kind of interferes with one another. So, like in the first problem, for example, we have a heterogeneous parent crossed with the recessive, and the way she explained in the movie is that we want to take the two observed traits that are like have the most, and those are the parental parents. You know, like for example, in problem one, there were 2,349 of the colorless waxy plump and 2,216 of the colored non-waxy shrunken. So for the first
Hmm.
problem, it says determine the allele arrangement in the heterogeneous parent. Basically, just determine on which chromosomes are the um, dominant and recessive parts are. We know there are 3 dominant and 3 recessive because it's heterozygous,
Mm-hmm.
but we just got to figure out on which chromosome are they on. So, and we do that by figuring out the phenotype of the most numerous parent offspring.
Yep.
So, like for example, in the 2,349 colorless waxy plump, colorless is recessive, so it's little c, and then waxy is recessive, so it's WX,
Mm-hmm.
and then
Plump's dominant.
yeah, plump is dominant. That means the 2 recessives and then the dominant are together. And if you look at the other one, it's exactly the opposite, where the 2 dominant and the 1 recessive are together. So that's how you figure out part A.
Cool. I can do B, I guess. So for B, when we're trying to figure out the gene order, we take and find where double crossover has occurred, and that's always the 2 least with the least number of offspring. So in this case, that would be the colorless waxy shrunken and the colored non-waxy plump. So what we do, again, just like Nick explained, we write out the genotype for these, and then we take the parental and trying to figure out like how the crossover can occur in order to make these 2 genotypes. So we do that by setting up and set up the parental with like a few in the what I did was I wrote like them in the middle just like she did in the video, and like kind of drew a little line like that to show that that's where the double crossover is occurring. And here we found that the gene order is little c, then dominant for SH. So the gene order is C, which is colorless, and then plump and waxy. So C, capital S, H, W, small letter WX, and then on the other side we have just the opposite to that.
Exactly. Now I have a quick question. So
Okay.
in the middle, she talked about it is the important part. Like we just
Sorry. Say that again?
Sorry. So for the answer on part B, like the middle part is the important part, like which in this case is the SH. But you said for the 2 ends, whether you put the C or the WX on either end, it doesn't matter, right?
No.
No, it's because it's gonna come out the same, right?
Yeah.
Yeah, that's kind of the impression that I got. So because I asked because in the key, like she has it backwards, and I think she said the video the same.
So when it says double crossover, is it 2 genes that are crossing over? So what really happens there, isn't it the C and the WX that swaps?
Yeah. Right?
That's what because isn't that what double crossover does? Because it's 3 genes that 2 of them are switching places. So I mean, it's the same as the middle one is switching place. It doesn't really matter, I suppose. Right. But you can think of it both ways.
Because either way, it's going to change it, right?
Yeah, I mean, they will both yield the same result.
If
the middle is changing or the 2 on the sides are changing.
Right, exactly. So, I mean, I always kind of looked at double crossovers, when the 2 chromosomes are next to each other and they're crossing over.
Right.
Like, goes over once, like it crosses over once, and then it crosses over like a second time back to the original chromosome. So, and I always figured that gave the least amount of offspring because it's so likely to happen.
Right. Exactly. Okay.
Then I just kind of had like a conceptual question. So you know how the distance affects the frequency of the recombination?
Yeah.
so like there's distance between the genes. So is it? I just don't really understand.
So the
how
further
that
apart they are, the more likely it is to occur.
farther apart?
Yeah.
Yeah.
So if the closer they are to each other, the less likely they are to occur.
So I just don't understand why that happens.
Here, I might be able to offer an explanation. So my understanding is like, kind of think of it like it's like a railroad track. Like you're going down it, you know, and the longer it is, the more likely it will like cross over. Like there's more positions that it can cross over on. So
Okay,
you know,
yeah.
So if you only have
there's just more possibilities.
pretty much, yeah, you know,
Okay.
and like the longer it is, like the more there's a chance that it can cross over, because you know it crossing which point it crosses over is completely random. But if there are more spots for it to cross over, then it's more likely it'll cross over.
It's a good explanation.
Yeah,
That's
really helpful.
I know. I remember when I was introduced to that in Bio 181, where they kind of like, and they just kind of mentioned it in passing, where it's like, oh yeah, further apart they are, like the more likely they'll cross over, and that didn't make any sense to me. So
Now it does.
yeah, now it does. Woohoo! Okay, now
All
do you
right.
want, or did you just barely do it?
Do you want to do C? Natalie?
Oh, sorry. For when?
Yeah.
Mhm.
Okay, so that was the linkage map distances.
Mhm.
Right. Okay. So I think it was the dominant W recessive X over the recessive W and X, and they had a greater distance, the 29.2, right?
Mhm.
Is that what you guys got?
Yeah.
WSH, is that what you said?
Oh, yeah, to SH.
Okay.
And then that goes to the C, and there's the shortest distance there. It's just 3.2.
Yeah.
And that was just with the little formula that they have in the PowerPoint.
And that's for one crossover, right?
Mm-hmm. A single crossover, yeah.
Yeah.
Okay.
Cool,
So,
and then we just calculate the inference for that.
And that was just 0.44, right?
yeah, 0.44,
Okay.
just about. So, I mean, so my understanding in the video she mentioned about positive interference, and I think it's any time that it's basically positive, right? I mean, you would get negative interference if what you observed was more than what was expected, right?
Yeah.
Mm-hmm.
The calculations that'll make it greater than 1, so it'll be a negative number.
All right.
Okay. Did you want to ask about the other assignment then?
Yeah. So I'll stop recording now.
Okay.